Welcome to Tensor Calculus Problem of the Day, posted on 7/25. Okay, in the last video, we looked at the tensor equation for the cross product, and we used this here. A cross B is equal to the Levi-Civita symbol times these components and the basis vectors, okay? Today, we want to use the same format to investigate the tensor equation for the curl. Remember the curl? Okay, so what can we do here? Well, we can try just substituting in the del operator for A, which would give us this expression, but look, there's something missing here. It's not a tensor equation. So in other words, the user doesn't know what to do. How do you expand this? You can't, because there's not enough information. What if we just pop this baby in, the covariant derivative? Now we've got a proper tensor equation, okay? So the problem for today is prove that the curl of this vector B, which we just looked at, I'm putting these parentheses here to emphasize that the covariant derivative is acting on this vector component, okay? Because you know that the basis vectors are metronomic anyway. They don't get involved. They can just come all the way out here, but I left it in the format. So prove that this reduces to simply the partial derivative of this vector component with respect to a coordinate. Okay, got a couple hints here. Use the summation index swapping, which we've done that many times, right? When you have summation indexes, you can change them as long as you keep everything straight. And the fact that when you permute this Levi-Civita, the tensor with an, see, I move the k to the middle, so that's an odd permutation, so you pick up a negative. If you use these two hints, you should be able to do that. Okay, I'll post the solution tomorrow. See you later.